Alright, so we're going to talk a little bit about questions that are going to show up on your momentum exam. So one thing you got to remember is that this little unit right here is an absolute value around a J, and the J is because they don't want to use I. We're going to use I when it comes to angular momentum. So J is just the impulse. Remember, J, absolute value, is impulse. And impulse, which is equal to change in momentum. Change in momentum. So change in momentum is equal to mass times change in velocity. Because the mass isn't changing, so mass times change in velocity. Well, M, if you think about this, force equals MA, and A is change in velocity over time. So, which is equal to mass times change in velocity over time. So if we multiply both sides by time, then force times time equals mass times change in velocity, which is equal to impulse. Okay, so just so that's cool, everybody understands where impulse comes from, right? So we're going to consider all that same. Okay, so impulse, oh, I erased part of my truck, but that's all right. You get the gist. Okay. So 8,000 kilogram car. So let me go back to marker here. Mass equals 800 kilograms. 800 kilograms. And traveling 13, velocity is 13 meters per second. And it collides with a 3,000 kilogram semi, so M2. So we'll call that M1V1. M2 is 3,000 kilograms, initially at rest, so that means V2 is 0. So that means M1 V1 plus M2 V2 equals M1 plus M2 times V. Oh wait, take that back. That is not happening. This is if they were colliding and sticking together, but that's not happening. So instead, we got M1 plus M1 V1, M2 V2 is equal to M1 V1 prime plus M2 V2 prime. So the question is, what is the change in momentum of the car? What is the change in momentum of the truck? And whatever the car loses, the truck gains, and vice versa. Okay, so the initial momentum before the collision lasts for 0.7 seconds, so the time equals 0.7 seconds, and the average force is 18,600 newtons. So force equals 18,600 newtons. And then force times time equals the impulse. So our impulse is equal to 18,600 times 0.7, which is equal to 13,020. So the impulse is 13,020, 13020, and that's in kilogram meters per second. And then what that means before the collision is M1 V1. So 800 times 13, 800 times 13 is equal to 10,400. Oh, 10,400 kilogram meters per second. And before the collision, the truck had 0 kilogram meters per second. Okay, after the collision, the car either lost or gained. So if the truck had none, now the truck is going to gain 13,020. So the truck after the collision is 13,020 kilogram meters per second. Then that means the car is going to lose 13,020. So 10,400. 10,400 minus 1320 is equal to minus 13,020, negative 2620. So the momentum of the car is negative 2620 kilogram meters per second. Okay, so what's the car's final speed and direction? Well, this is the car's final momentum equals negative 2620 kilogram meters per second. And that's negative, so that means it's moving to the left. And that's equal to the mass of the car times the velocity of the car. So this is 2620. Negative means left facing, so the mass of the car is 800 kilograms. So 2620 divided by 800 equals 3.275 meters per second to the left. So 3.28 meters per second left. And the truck's final speed and direction, well, the truck is going to have 13,020 kilogram meters per second. So for the truck, 13,020 kilogram meters per second divided by 3,000 kilograms, it will give you the velocity of the truck, which is 13,020 divided by 3,000, 4.34 meters per second. Okay, so that's to the right because it's positive, so we're going that way. Okay, so that's 4.34 meters per second to the right. Okay, now similarly, the other, let's see here. The other questions are actually similar questions, so they're going to ask another one with a different sort of setup, but it's the same process here. So we got a collision. It's originally, this one's 0 and this one has some momentum, and then that change in momentum is the 0.9 seconds. The semi-truck ends up moving 5 meters per second to the right. So the semi-truck didn't change mass initially at rest, so that means it had 0 momentum to begin with, but it had a mass of 3,000 kilograms, so it ends up moving 5 meters per second to the right. So 3,000 times 5 is 15,000 units to the right. So after the collision it was 15,000. Before the collision it was 0, so the change is 15,000 kilogram meters per second. So then it'll ask what's the magnitude of the average impact force. So you take that divided by 0.9, and that force will be quite big. Okay, so there's those, and then let's see here. Similar, where the initial momentum of this system is 0, so you've got some momentum of the ball moving to the right, momentum of the cannon moving to the left. Remember, the left is negative, ball moving to the right is positive, etc. Similar again, only this time they stick together. Lock together inelastically, following the collision, which lasts that many 0.4 seconds. So then m times v to the right, m times v to the left. This is negative. So this momentum positive minus this momentum negative. If they end up stationary, then would equal 0. But if not stationary, then you go the direction of the bigger original momentum. This is fired at an angle, so you're looking at horizontal speed versus vertical speed. So make sure you keep that straight. These are pretty easy. This collision causes both vehicles to immediately stop. Okay? So it means the momentum coming in equals the momentum coming in from the other direction. So you can work that magic. Same thing here. Collision causes both vehicles to stop immediately. That means their momentums are identical but in opposite direction. Okay, so this one has a change in momentum of 5,000 meters per second. So if, let's say, this 7,000 kilogram meters per second loses 5,000, this one's going to gain 5,000. So if it's going 4,000 and it gains 5,000, it's going to have 9,000 at the end. This one's going to be 7,000 and lose 5,000. So 7,000 minus 5,000 would be 2,000. You get the gist. So whatever momentum is lost by one is gained by the other. Okay. Another little nifty thing is to make sure you know that when you see little lines behind the vehicle, that's implying that it's moving. So when there's no lines, it's not moving. That's that. Like right here, there's no lines, so it's assuming the car is at rest. And the truck has 3 little lines behind it, so that means it's moving. Same kind of thing. Figure out what the change in momentum is and put it here. And whatever the momentum change is in the truck is equal to the momentum change of the car. So it should be pretty straightforward for that. And then, yeah, we got that question. It's just hitting momentum. Hitting momentum. Different momentum questions. Now, your test may or may not have the same questions on it, but it's going to have the same types of questions on it. So should be pretty straightforward. And yeah, we should do well. So you guys make sure and let me know if you have questions before we start. And we'll talk soon. See ya.